is a common term used in economics, but they are a large part of everything from how we regulate our body to climate change. A feedback loop is a process in which one situation's output is used as input in a new situation. So a positive feedback loop amplifies change. The first situation causes the second, which causes the first to speed up. A negative feedback loop opposes or resists change, which is a little harder to explain. An example would be how our body regulates temperature. When you're hot, your body sweats, which lowers your body temperature, but it stops before you get too cold. So positive feedback loops seem to snowball out of control until something interrupts the cycle, whereas negative feedback loops seem to balance out eventually. I would like to look at feedback loops on the large scale pertaining to climate change. First up, sea ice, the most popular positive feedback loop for climate change. Sea ice is extremely reflective, so as the planet warms and the ice melts, less sunlight is being reflected by the ice and more is being absorbed by the dark ocean water. So this water warms, which melts more ice and pushes the cycle on. Another common positive feedback loop is the release of methane from ice and permafrost. Methane is a very efficient greenhouse gas, and bubbles of this stuff is abundant in ice and permafrost. So when these melt and the methane is released, the planet only gets warmer, causing more ice and permafrost to melt. A similar process is shown with the ripening of apples. A ripe or injured apple will give off a gas called ethylene, which causes surrounding apples to ripen. So when an overripe apple is placed with a fresh one, the ethylene from the first apple causes the second to ripen and also release ethylene. This is why we say one bad apple can spoil the whole bunch. I wanted to show this process, but the one time I bought fruit with the intention of it rotting quickly, it did not. So on to a negative feedback loop for climate change. This one has to do with CO2 and plants. As carbon dioxide levels rise in our atmosphere, the global temperature increases. This heat increases the rate of photosynthesis in plants. With more photosynthesis happening, excess CO2 is removed from the atmosphere, reducing the greenhouse effect and the warming. Something I found interesting that pertains to feedback loops is called global dimming. I watched a documentary called Global Dimming in my chemistry class recently, and it brought an interesting issue to my attention. It explained the obvious of excess greenhouse gases from the burning of fossil fuel causing a warming trend. But then it goes on to talk about particulate matter pollution. The tiny particles released from the burning of coal and other industrial processes can cause clouds to become more reflective. This increase in Earth's albedo can cause a cooling trend. This is not saying we're safe from climate change if we burn the dirtiest coal we can find, but if we had taken particulate matter out of the equation from the beginning, how much warmer would our planet be? And would we have started to change earlier? All of this just goes to show how delicate and interconnected systems are on our planet, and how a little knowledge on feedback loops can help you understand climate change better and how it affects us.